So let's start with our second one. So question number 2, here it is, very important and conceptually very important question number 2. Okay, so focus on this. Okay, these things you must have done in first term, but this will be a good revision. And let me repeat again, this is electrostatics, means you have first and second chapter both. Okay, so let's start with question number 2. In question number 2 it says 3 concentric charged metallic spherical shells A, B and C, radii A, B and small c, okay, each having charge densities sigma, minus sigma and plus sigma, and their potentials are VA, VB and VC. Which of the following relation is correct? Okay, so let's try to make a diagram. Okay, let's try to make a diagram and try to simplify it. Okay, so let me write here 3 concentric circle. Let me draw 3 concentric. This is the first one I am drawing here. Okay, then I am drawing the second one here. Okay, and this is the third one. Okay, this is the third metallic sphere with shells with A, B, C. Okay, what's the name of each one? The name of the first one is A, second one is B, third one is C. Now please focus, this is very important conceptual problem. Okay, and very like million times repeated question in many exams, not only in GSET. Okay, now radii of each one is small a. The first one I am making here small a, the second one I am making here B, and the third one is C. So this is your A, B and C. I hope this is clear. The radii of first sphere or shell is A, the second sphere is B and the third one is C. Okay, next, surface charge densities. Now those who don't know what are surface charge densities, surface charge density means sigma is charge per unit area, and in case of sphere this area will be 4 pi r square, in case if you don't know. Surface charge density, how the charge is spreaded over the given area. Okay, so for the first one it is sigma, the second one it is minus sigma, and the third one it is plus sigma. Okay, now be very careful here, the sigma is very important part, because sigma we have to express our result in terms of sigma. Okay, the first thought which will come into our mind is, sir, are we given with the charge? No. So what is our basic thing we have to figure out in this situation? Sir, you have to figure out first charge. So let's figure out charge for each sphere. What is the charge on the first sphere? QA, and that will be equals to sigma into area of the first sphere, right? Using this relation. So 4 pi a square. Equation number 1. I hope no one has any doubt in this. Let me repeat again. Charge is equals to surface charge density into area. Okay. Sir, why there is 4 pi a square? Because it's a sphere, it's not a circle. Let me repeat, this is a sphere, that's why it is 4 pi a square. Okay, that's the area of sphere. Next is QB, the charge on the second sphere, that will be equals to sigma plus or minus? Minus. Be very careful, charge is a scalar quantity, it's not a vector quantity that you can ignore the negative sign. Okay, because there the negative sign represents direction, so we are not going into that right now. Right now charge is a scalar quantity, so minus sigma. And what's the area of the second one? 4 pi b square. I hope this is also clear to all of you. Let's move ahead and see the third one. What's the charge on the third one? QC, that will be equals to sigma into 4 pi c square. That's equation number 3. I hope this is clear to all of you. Okay. Now, once you got your QA, QB, QC, all the charges on A, B, C, now let's proceed to the question, because now it will become quite easy for us to proceed. Now question says each one has a potential VA, VB and VC. Which of the following relation is correct for this given part? Okay, so let's start finding VA, VB and VC. Now you have to be very careful with this relation this time. V is equals to K Q by R. This relation is very simple. It looks very simple for one charge, but if you have a charge densities like this and they are grouped like this, like concentric spheres, okay, then you have to be very careful. Okay, so K is constant, Q is the charge and R is the position at which you are finding. Okay, so first of all we will find potential due to the first one. Now pay attention here very carefully. So potential here will be VA, which is the potential on the first sphere. Listen very carefully. will be due to the first sphere, due to the second sphere, due to the third sphere. Let me repeat, the potential, the net potential at this location, which location? At this location. Let me make here again this circle, okay, this at this location, the potential will be due to all three, because charges contribute. We follow superposition principle, remember, from first term. So the potential at A will be due to A, B and C. So this will be, let's take, because it will be K charge on A upon the position of A plus K charge on B. Okay, be very careful, this R is the position from the center. So what will be the position here? It will be B, small b, and plus K Q C upon C. Let me repeat again, potential at A due to the first one, first charge distribution. First charge distribution is distributed from the center as A. The second charge distribution from the center is at B. And the third charge distribution from the center is at C. So the potential contributed by each will be in terms of this, KQ by R. I hope this is clear. Can we substitute here values? Yes, let's substitute the values. So K will be 1 by 4 pi epsilon naught outside. QA, what's QA? Sigma into 4 pi A square upon A plus sigma into 4 pi B square upon B plus sigma into 4 pi C square upon C. Let's take, let me just increase the size. Now let's take our, let's move a little that side. Let's take 4 pi common out and cancel out, and sigma also taking common out. It will give you sigma upon epsilon naught A plus B plus C. I hope this is clear. I have done a small, yes, exactly, that's what I was coming to. I have done a small mistake. Okay, now I got your message. The sigma must be negative from equation 2. So since it is negative, this B will be negative. So this will be a negative sign here. This is a negative sign here. So this is your potential due to the first shell, equation number 1. I hope this is clear to all of you. Okay, let's keep it there. Is there any option like this? No, there is no option. So this option, first option goes wrong. Okay, this is not true. Okay, let's move ahead and see what is potential due to B. Okay, now you have to be again very careful. Let's recall our property of metallic conductors. For any given metallic conductor, the potential inside the sphere or inside the conductor is constant. Let me repeat, potential inside a conductor is always constant. Why potential is constant inside the conductor? Because its electric field is 0. Let me repeat again, if electric field is 0, the potential will remain constant. And we will use that property for B. Why and how? Let's see. So potential due to on metallic sphere B will be equals to, pay attention, that will be equals to our K. Let's take K out only, because K is common for each one of them. Charge on A contributing to B. So location is what? What's the new location of this? B, plus charge on B upon B only, plus charge of C upon B. This is very, very important. Sorry, this is C. Very important concept. Charge on C, the outer value of length. Let me repeat again. If you are looking for the potential at this location on this second sphere, at this location, then you have to be very careful. The charge on A that is contributing its potential at the location B. So charge due to B will have already B, and charge due to C will have C. This is very important property of a conductor. The potential will remain constant inside it. So that's why we are taking here both the B same. Okay, so let's substitute here values. So K is 1 by 4 pi epsilon naught, and QA is how much? QA is sigma into 4 pi. So 4 pi we will cancel out all, sigma 4 pi A square upon B plus sigma 4 pi B square upon, sorry, minus it is, again this is negative, minus upon B, and finally sigma 4 pi C square upon C. Let's see what we get the potential for B. That will be equals to, now 4 pi I am cancelling, sigma I am taking out, it will be sigma by epsilon naught A square upon B minus B and plus C. So potential VB, option B is correct. Similarly, you can find VC yourself, because since I got the correct answer, I am not moving ahead. Okay, I hope that you can do yourself at home and find if sigma VC is correct or not. Okay, so in a similar fashion you can find VC also. Okay.